Hey guys, welcome to ANS Solver. Today we'll be learning the sketching of linear and modulus graphs, which is a subtopic in the chapter of Algebra P2. Okay, so basically we'll first look at linear graphs. Okay, before graphing it out, you need to know what's a linear equation. Okay, really simple. Linear equation has something like y equals to mx plus c, like the form, correct? Where y is the y coordinate, m is the gradient, x is the x coordinate, and c is the y intercept. Okay, so you know this is a basic concept which we have learned. Okay, let's say linear equation will look something like y equals to 5x plus 2, something like this. Okay, this is basically a linear equation. This is an example. Now let's come to modulus equations. Okay, modulus equations, I'll just write here. Okay, modulus equations will look something like y equals to, okay, I'll give a straight away example, the mod of x minus 5, let's say, correct? Basically the mod will be there. Okay, a very important concept to know about modulus graphs is that these graphs are v-shaped. Okay, these have v-shaped graphs. Okay, this is a very important concept to know. Got it? Now let's do another important concept of how do we graph something like this, whether it be linear equations or modulus equations. We need something called as the intercepts. Okay, we need something called as the intercepts. Okay, so what does intercept mean? It basically means the x-intercept. Okay, at the x-intercept, my y needs to be equal to 0. Correct? And at my y-intercept, okay, my x needs to be equal to 0. Correct? This is the basic concept which you need to know about intercepts. Now, let's say I have my function as y equals to 5x plus 2. Okay, let's take the same example. What are the set of coordinates, okay, which I need to graph this? Okay, first I can take my y as 0. When I have my y as 0, okay, I basically I'll do the working with blue. Okay, I'll do the working somewhere here. So I'll basically get 0 equals to 5x plus 2. Then I'll get minus 2 equals to 5x. And I'll get x equals to minus 2 over 5. Correct? This is what I get. So I get my x, which is equal to minus 2 over 5. The next thing I do is I take my x as 0. When I take my x as 0, I simply get y equals to 5 into 0, which is 0, plus 2. So I get my y basically as 2. So the coordinates are always x comma y. Correct? The coordinates are always x comma y. Something like this. So the set of coordinates which I have is simply minus 2 over 5 comma 0. Correct? And 0 comma 2. Correct? We learn how to graph it later, but now these are basically the coordinates which I have. In the same way, let's say I have the modulus function here, y equals to the mod of x minus 5. Correct? First find the set of coordinates. So what I do is I take my y as 0 here. Correct? So when I take my y as 0, I'll again do the working with blue. Okay? So I basically get 0 equals to the mod of x minus 5. Correct? Which is basically x minus 5 equals to 0. Correct? Because 0 is not negative or positive. Correct? So you get your x basically as 5. Got it? So you basically get your x here as 5. Now take your x as 0. When you take your x as 0, you basically get y equals to 0 minus 5 mod. And the mod of minus 5 is simply 5. So I get my y also as 5. Now I know it's x comma y. So I can write this as 5 comma 0 and 0 comma 5. These are the basic coordinates. Correct? Understood the intercept concept and how to get the two coordinates? Now what we can do is we can go ahead and try to graph these. So the first thing which we'll graph is y equals to 5x plus 2. Correct? The linear function. So for that, I have my coordinates basically as minus 2 over 5 comma 0, okay, which lies somewhere here. Okay, this is minus, or actually this is, let's say it lies somewhere here. You don't need to be to scale, okay, because it's a sketch. Okay, so it needs to be an approximate, not to scale. So I know minus 2 over 5 comma 0 will lie somewhere here. Got it? Now 0 comma 2 will lie somewhere here. Okay, now the linear graph is always a straight line, so it will basically look, first draw this, then it will basically look something like this first. Okay, it will basically look something like this. It's basically a straight line. Correct? So this will be the graph for y equals to 5x plus 2. Okay, simple linear graph. Now what we can do is we can simply make y equals to the mod of x minus 5. Okay, so it has the coordinates 0 comma 5 and 5 comma 0. Correct? So first I have 0 comma 5, okay, which lies somewhere here. Then I have 5 comma 0, which let's say lies somewhere here. Okay, I'll just extend this graph here, so that, because this goes up till here actually. Correct? So I'll basically get y equals to 5x plus 2 here. Okay, this is what I simply get. Now I want to graph y equals to the mod of x minus 5. Okay, so the graph to do that will look something like, first I'll make a line here. Correct? Remember, it's a mod graph, so it cannot be negative. Okay, so that means I know it's a V-shaped curve because that's the most important property here, because it cannot be negative. So it will look basically something like this. Correct? This is how it will look. But now, like here we wrote y equals to 5x plus 2 simply. Okay, here we cannot just write it simply. What we need to do here is, you need to know that the right hand side of the graph, this is of the modulus graph. I'll just remove the red line so that you're sure. Okay, I'll just remove it so that you're 100% sure of what I'm saying, because the linear graph is easy to sketch, but the modulus graph is a little tricky sometimes. Okay, so basically this is the modulus graph which you have. Now the right hand side of the graph, okay, is basically y equals to x minus 5. Correct? As it is. Okay, nothing positive, nothing negative. Okay, but the left hand side of the graph is y equals to minus of x minus 5, which is basically equal to minus x plus 5. Correct? This is what you basically need to know. Okay, the left hand side is always a negative of the function, and the right hand side is always the positive of the function. Okay, this is a very, very important concept to know, as this is a V-shaped curve. Okay, because it can never be negative, it can never go to this side. Okay, because it's it cannot be negative. Modulus is always an absolute value. It always gives an absolute value. Okay, this is what you need to know. Okay, so this is the basic concept of graphing. Now what we can do is, we can do some past paper examples. Okay, so this was the question in 2020, May, June, paper 22. Okay, so sketch on the same diagram the graphs of y equals to the mod of 2x minus 3 and y equals to 3x plus 5. So first I have y equals to the mod of 2x minus 3. Okay, there's another important concept. Sorry, I'm just, interrupting. There's another important concept which we'll do in this sum, which is basically the B part of this sum. Okay, so that's a very important concept. I'll teach you how to do it. It's really simple, but it's important. Okay, so yeah, coming back to the sum, y equals to the mod of 2x minus 3. So here, basically what I do first is, I take, let's say, my y as 0. So when I have my y as 0, okay, I basically get 0, which is equal to the mod of 2x minus 3. So I simply get 3 equals to 2x and x equals to 3 over 2. So I get my x here basically as 3 over 2. Got it? Correct? So I'll just remove this working. Okay. Now I take my x as 0. When I have my x as 0, I know 2x is basically 0 and the mod of minus 3 is 3. So I get my y basically as 3. So the coordinates I have simply 3 over 2 comma 0, correct, and 0 comma 3, correct. This is for the modulus function. Now the linear, which is y equals to 3x plus 5. So first I take my y as 0. So when I take my y as 0, I simply get 0 equals to 3x plus 5. So I simply just get minus 5 equals to 3x, where I get my x basically as minus 5 over 3. Correct? I basically get this. I'll erase the working again. It's simple working. Okay. Now what I simply do is I take my x as 0. When I take my x as 0, I get my y basically as 5. So now the coordinates I have is minus 5 over 3 comma 0, correct, and 0 comma 5. These are the coordinates which I have for the linear graph. So what we can first do is we can sketch the modulus graph. So I'll do that with red. So I have 3 over 2 comma 0. So I know 0 lies here. Okay. Now I have 3 over 2 comma 0, which let's say lies somewhere here. Okay, this is 3 over 2. So let's say this is one coordinate here. And the second coordinate I have is 0 comma 3. Okay, 0 comma 3, let's say lies somewhere here. It needs to be a sketch. Okay, and remember that this is a modulus graph. Correct? So it's basically a V-shaped graph. Correct? Which will look something like this. Now, the important thing which you need to know, the right hand side will basically be y equals to 2x minus 3, correct, as it is. And the left hand side will be y equals to minus of 2x minus 3, which can be written as y equals to minus 2x plus 3. Correct? This is how you can write it. So I'll just remove this so that you have only one equation. So it's y equals to minus 2x plus 3. Got it? So this is how the modulus graph will be sketched. Now the linear, I'll make the linear with blue. So I have minus 5 over 3 comma 0. Let's say which lies somewhere here. So I have minus 5 over 3. Correct? And I have 0 comma 5, which let's say lies somewhere here. Correct? These are the coordinates which I can simply say. And this is basically a linear graph. So first I'll make something like this. Correct? Then I can make this and then this. Correct? This is what I can simply do. And the graph will simply be y equals to 3x plus 5. Correct? This is what I simply get. Now, what I can simply do is, I can go to the B part. I need to solve the inequality where 3x plus 5 is less than the mod of 2x minus 3. Okay? So now, what I basically need to do here is, we need to think about this logically. This is a new type of question. Okay, you can do two things. First, you can square both the sides and do like how we solve normal inequalities. We can do it like that. Okay, that's one thing which we can do. Or the second thing is, the smart thing is using the graph. So basically, first calculate something called as the point of intersection. Okay, this is basically the point of intersection. Basically, where are the graphs intersecting? As you can see here, we have one point of intersection. Correct? Here I have one point of intersection. Okay, which lies somewhere here. Correct? If you see, the graphs are basically intersecting for 3x plus 5, correct, and minus 2x plus 3. Correct? So I can simply first write 3x plus 5, which is equal to minus 2x plus 3. Correct? So now what I can do is I can write this as 3x plus 2x, which is equal to 3 minus 5. So now I can write this as 5x, which is equal to 3 minus 5 is simply minus 2. So I get my x basically as minus 2 over 5. Correct? I'll just write this in better handwriting. This is minus 2 over 5. So this is basically the x coordinate of the point of intersection. But now this is equal to. We need to determine a sign. So now this is really important. You really need to understand this. How do we determine the sign? So the point of intersection is the green line, the green dotted line. Now what you need to do is simple. Let's say I'm using the purple color here. Okay, make a line which is more than the point of intersection. Okay, which looks something like this. And make a line which is, let's say, less than the point of intersection, which is somewhere here. Make two lines. Got it? One is less, one is more. Now see what you need. You need the linear curve or the linear equation to be less than the modulus in the modulus equation. Correct? So if you see here, okay, where is the modulus equation, which in this case is minus 2x plus 3? Where is the y coordinate of minus 2x plus 3 more than the y coordinate of 3x plus 5? Correct? Basically, what I mean to say is, if I make a line, let's say here, okay, and if I make a line here, the y coordinate of the blue line is more than the y coordinate of the red line, which we don't need. We need the red line to be more than the blue line. Correct? Obviously. So if, let's say, I see here the y coordinate of the red line is more than the y coordinate of the blue line. Agreed? And that's what we need, because I need the modulus function to be more than the linear function. So basically, and where does this point lie here? This x coordinate lie? It lies less than the point of intersection. So basically, what I simply do is I write x, which is less than minus 2 over 5. Correct? This is basically the answer. This is how you determine the sign in the middle. Okay? Got it? So I'll explain this concept again. Basically what I did is I made two purple lines. One which is more than the point of intersection, one which is less than the point of intersection. Okay? Then I saw what I needed. I needed the modulus graph to be more than the linear graph. And basically I need the y coordinate of the modulus graph, which is more than the y coordinate of the linear graph. Basically the red line should have a higher y coordinate than the blue line. And I saw at this purple line here, okay, the y coordinate of the modulus was more than the y coordinate of the linear. And if you can see this purple line here, is less than, okay, the point of intersection, which is somewhere here. So that's why I simply just took x, which is less than minus 2 over 5. Okay, this is basically the logical approach. But yeah, you can also solve this in the algebra way by, squaring both the sides and getting the answer, which we did in the previous video. But yeah, this is basically smart work which you can use and simply get 3 marks. Got it? Now, let's go to another past paper example. So this question had come in 2020 Feb March paper 32. The first question. So part A, we need to sketch the graph y equals to the mod of x minus 2. Really simple. First take your y as 0. So I simply get the mod of x minus 2 equals to 0. So I get my x minus 2 equals to 0. So I get my x basically as 2. Correct? Now, when my x is equal to 2, basically, now I have one set of coordinates here. I take my x as 0. When I get my x as 0, I get y equals to the mod of minus 2. The mod of minus 2 is simply 2. So I simply get y equals to 2. Correct? So the set of coordinates which I have is simply 2, 0 and 0, 2. Correct? So now to graph this, I have 0 somewhere here. Okay? So first I'll simply do, let's say with a red pencil, I have 2, 0. Where does 2, 0 lie? Let's say it lies somewhere here. Okay? Or actually this is too close. Let's say this lies somewhere here. You don't need to make it to scale. It's just a sketch. And 0, 2 lies somewhere here. Correct? This is what I can simply do. So now I can simply make a V-shaped curve. Correct? Actually, just give me 1 second. I'll just graph this in a better way. Okay. Let's say my 2 is somewhere here. Yeah. Now it's perfect. So I have this thing somewhere here. Something like this. And I have this thing something here. Okay, because it's a mod graph. So it has to be V-shaped. Now, I know the right hand side of the graph will basically be y equals to x minus 2. And the left hand side will basically be y equals to minus of x minus 2. Okay, which can be written as y equals to minus x plus 2. Got it? So I'll just erase this. So this is basically the sketch. Now I can go to the B part. Here I need to solve the inequality where the mod of x minus 2 is less than 3x minus 4. So the first thing we need to do is we need to graph y equals to 3x minus 4, which here is a linear equation. So first we take my y as 0. When I take my y as 0, I basically get 0 equals to 3x minus 4. So I get 4 equals to 3x and x equals to 4 over 3. Correct? So I get my x here basically as 4 over 3. Now I take my x as 0. When I take my x as 0, I basically get my y as minus 4. So I can simply write this as 4 over 3, 0, okay, and 0, minus 4. Correct? These are basically the coordinates. So what you can do is with a pencil, okay, because it's not asked directly. So what you can do is with a pencil, basically sketch these. So you have 4 over 3, 0. Where is 4 over 3? It's somewhere here, let's say. Correct? Sorry, actually I'll write this with a proper, not the dotted. Okay, just give me 1 second. Okay, so I have 4 over 3 here, 0, and I have 0, minus 4. 0, minus 4, let's say lies somewhere here. Now with a pencil, what you can do is, simply so that you can erase it later, okay, what you can simply do is, you can simply Actually, it is not straight. Just give me one moment. Yeah. You can simply make a line first here, something like this. Okay. Then a linear line, a straight line basically. Okay. Which looks something like this. Correct? This is what you'll basically get. Now, what you can simply do is, you can see there's one point of intersection here. So you need to calculate the the POI, the point of intersection. So for that, you can see that this thing here is basically y equals to 3x minus 4. Correct? Write this with pencil also. So now you can see there's one point of intersection here. Correct? So that's basically y equals to 3x minus 4 intersecting with x minus x plus 2. So you can write this as 3x minus 4, which is equal to minus x plus 2. Okay, so I can rearrange this and write this as 3x plus x, which is equal to 2 plus 4. So I can write this simply as 4x, which is equal to 6. So I get my x basically as 6 over 4. So I get my x basically as 6 over 4, which is 3 over 2. Correct? This is what I basically get as my x. Correct? Which is basically the point of intersection somewhere. Okay? Now, what I need to do is, I need to determine the sign, which is really important. Okay? So I can take the purple. Okay? Here, I need the modulus to be less than the linear. Okay? So, simple logic. Take a line which is more than the point of intersection. Take a line which is less than the point of intersection. Okay, not here, actually it will be a little more closer. Let's say I take somewhere here. Okay. Now, what do you need? You need the green dotted line y coordinate to be more than the red. Correct? And if you see here, the y coordinate here, which the green dotted line produces, and the y coordinate here, which the red line produces, the green dotted line produces a higher y coordinate. And that's what you need, because you need 3x minus 4 to be more than the modulus inequality. That means this purple line right here satisfies the inequality and it lies more than the point of intersection, because the point of intersection is here in black. That means I simply write my answer here as x more than 3 over 2, basically as the final answer. Correct? This is what I get as my final answer. So this was basically the concept of sketching linear and modulus graphs. But obviously in past papers, there are many more different types, okay, which obviously we've made video solutions also. We have provided video and pictorial solutions for. Okay, so please have a look. Please practice these kind of sums. Okay, it's a very good concept. It's mostly asked in paper 2 and sometimes asked in paper 3 also. Okay, so this was the end of the video. I hope you liked the video and enjoyed a lot. Okay, please view the next video to finish this chapter. Thank you very much.